All right, all right. Let's talk about inheritance with Java classes. What is inheritance? Inheritance is essentially a child class acquires behavior from the parent class, and not only the behavior, but the attributes as well. It uses the extends keyword, and it models as it and is a relationship. So check this out. We have a class called animal, and we have a class called dog. Dog extends animal. It's an extension of animal. It's a child class of animal. It is a animal. Well, it's an animal, but it is a. It is an animal. That's the is a relationship. Now let's take a look at a sample UML of class inheritance. And the main thing that you need to note is the solid line with the arrow. When you have an arrow pointing upwards like this, it points towards the parent class. So you have a child class inherited from the parent class. The key features of inheritance is the fact that you can reuse code. You can override methods, which means you can change the implementation of a child method, or rather, a method that a child inherits from the parent. It allows polymorphism, which ties into method overriding. And we will talk about overriding and polymorphism more in another lecture. But this is a nice introduction. And of course, it establishes a parent-child relationship. Basically, it establishes a hierarchical relationship. Like, for example, dog inherits from animal, and a wolf can inherit from a dog, because what are wolves but dogs that are evolved to be ferocious? Wolves are basically dogs evolved in the wild. So look at this. You have an animal, you have an animal which is a type animal being instantiated as a dog. This means that you can substitute the child, you can substitute this child class for the parent class. This child class has all the features and attributes of the parent class. And this animal, which is a dog class, can invoke the eat method. What are benefits of inheritance? Reduce duplication. So we want to keep our code dry. Dry means do not repeat yourself. And what better way than having a child class? Instead of rewriting the same code over and over again, you can have classes extend off of other classes. You can extend functionality off of other classes and add additional functionality in those child classes. Better maintainability, logical modeling. Yes, inheritance does help. Extensibility. Yes, we just talked about that. Loose coupling. So you can depend on parent types. Essentially, you can use a child class and substitute it for its parent's class because you know that a child class can do at least everything the parent class can do, and then some. It enables flexibility and promotes that polymorphism I was talking about, where you can inherit methods, override these methods. With inheritance, you can establish a class hierarchy. So a dog can inherit from a mammal, which inherits from an animal, which inherits from object, because every object in Java, whether built in or custom made, inherits from objects. However, there is a limit to inheritance. Java does not support multiple inheritance, but it does support single inheritance. Let me tell you why that is. You see, the issue runs into, let's say, okay, you have two parents that you're inheriting from. They both have the same method with the same method signature. You can see how the compiler would be confused. Which method am I going to use? Single inheritance eliminates that. And of course, there's the vertical structure that I have already alluded to. Let's talk about vertical constructor chaining for a bit. So whenever a child class invokes its constructor, it runs the parent constructor first. Let me say that again. When a child invokes its constructor, the parent constructor runs first. You'll see that in our live demo. And this is through the super keyword. So the super, it can be implicit or explicit. And it ensures a full initialization. We'll just touch on the protected keyword because I did an extensive discussion on that in our access modifiers lecture. But essentially what protected means is that visibility is within the package, and in a child class, the visibility can be outside the package. However, that visibility of the child class outside the package is within the child class itself, as you can see here. Like this int age is a protected attribute, a protected variable. However, this dog, if it's outside the package, it can still access this age variable, but it has to access it internally through a setter. The final keyword. I talked about the final keyword in the lecture when I introduced classes. So the final keyword is, as it says, it's final. So if you have a final class, you cannot extend this class. Like final class utility, if you try to inherit from this class, it won't compile. It's going to say, no way. You're not getting your way. It prevents overriding. So you cannot override a final method. You can inherit the method, you just can't override it. And it ensures stability. Now let's talk about abstract classes, because there is a time and a place for abstract classes. But the thing about abstract classes is it cannot be instantiated. So let's say, again, we have an animal class. This is an abstract class, and we have a dog class. Okay, but you can use these classes to enforce behavior, some partial implementation, and abstract classes can have both concrete and abstract methods. As a matter of fact, you can have an abstract class with no abstract methods. However, if you do have an abstract methods, the child class must, and I mean must, implement those methods. It's like a contract, a binding contract. So let's look at this abstract class animal. Okay, why are we using an abstract class here as opposed to just a regular class? I'll tell you one. Let's think about it. In the real world, you're not just looking for an animal, you're looking for a specific kind of animal, like a dog or a cat, maybe a wolf. Well, not really, wolves are dangerous. But the point is that animal can be used to grant certain behaviors and attributes to child classes. So that's one. So let's say, let's say, okay, you're a developer and you want to use this class so the child classes can inherit from it, but you don't want to instantiate the class itself. There are plenty of examples in even existing classes. So that's one. Okay. Two, abstract classes do not have to have abstract methods, but this one does. So essentially, an abstract method looks like this. In an abstract class, you have to use the abstract keyword. In interfaces, you don't, but we'll talk about interfaces later. It'll probably be my next lecture. So it makes sound. So what it does is it's called a method stub because it's just a stub. You don't have the implementation. But when you extend this class, you add the implementation. So now this dog will make a sound, which is a barking sound. Okay, when do we want to use inheritance? When there's a clear is-a relationship. We clearly want to extend our code. We want to reuse our code. We want that shared behavior, but we don't want to get too hierarchical. Like 1 or 2 levels of hierarchy is good, 10, not so much. So in a nutshell, inheritance enables reuse, hierarchy, and polymorphism when used correctly. Now we are back in Eclipse. And let's take a look at some of our classes and talk about inheritance a little bit. So before we run this runner class, which is called run class inheritance, and another thing about these lectures is all these runner classes are named after the current lesson. So let's look at our classes. So we have a parent class. So we have a parent class, and it has a constructor, it has a talk method. It even has a final method. But remember, final methods, they can be inherited, but they cannot be overridden. And then, of course, we have our getters and setters. Let's look at the child class. It is called child for a reason. So we have a child class. So here, I'm just going to remove this to avoid confusion for a minute. So here, we have the child constructor. It uses the super keyword. So with this super keyword, when the child constructor is called, the parent constructor is called first. Then the rest of the logic of the child constructor is carried out. So parent constructor and child constructor. And then we can override a method. So let's go back to our main. As a matter of fact, so let's comment out this overridden method for a second. Because even without putting anything else in the body of this class, this child will execute the parent methods. So let's go to our, one more thing. Here's a final class. This final class cannot be extended. I left it empty because it's just for demo purposes. So let's go to our run class inheritance, shall we? So we have a parent being instantiated with a parent name, and the child is being instantiated with a child name. So let's run this and see what happens. Okay, so the parent constructor was called. For the child constructor, the parent constructor was called first, then the child. And then the parent's talk method was invoked, the child's talk method was invoked, and the final method was invoked. So let's comment out the parent for a second and focus on the child. Because sometimes when you have children as parents, you have to give them that attention. And we will give them that attention now. So let's focus on the child. Let's see what happens with the child alone. So the only thing we're going to execute is instantiating a child instance, executing the child's talk method, and of course the child's final method, because why not? Okay, so as you can see here, the child called the parent constructor, then child constructor, invoked the parent's talk method, and invoked the final method. So let's make a few changes now. So let's go to our child class. Let's comment back in this overridden method. And one thing I should note is that even though we use the override modifier, you don't really need it. Without this override modifier, it'll still run. So I'll remove that too. Okay, see, and I have Copilot, so it's telling me to put it back in, but whatever. So let's run this now. So let's just go ahead and run it and see what happens. So now the child method. So this child method has been invoked. And you can see, even without the override annotation, you can still run this. The override functions more as a spell checker, but it's good practice to use it, so we're going to put it back in. Okay. And let's see what happens when we comment back in the final method. So as you can see, it's giving us an error. So it's saying you cannot override the final method from parent. All right. So that's one. Now let's look at one more thing. We're going to try to extend a final class. Let's comment this back out. And as one can see, you're getting a compiler. The type inherit from final class cannot subclass the final class, final class. So you can't inherit from final class. And I think with this, we're done with the IDE portion of this talk. Thank you very much. Subscribe. I'm out. See ya.